Okay, now let's take the question. It says if the minimum value of this particular function a tan square x plus b cot square x equals the maximum value of the other function where a and b are given in this relation that both are positive and a is greater than b, then you have to prove that a will be nothing but equal to 4b. Okay, let's see how we will do this first of all. So it is, let's say a function that is given to you is fx a tan square x plus b cot square x, right? This is given to you, and it is said that the minimum value of this particular function is equal to the maximum value of the other function, right? Maximum value of this other function which is in terms of a, b and theta, right? Clear? So let's first of all find the minimum value of this function. Okay, so how you will find minimum value of this function? Now, why I have taken this particular problem, that whenever we see maxima minima, we straight away start differentiating that particular quantity, and this is what is generally not asked at the engineering exams. So I'll show you how. There is a common pattern over here. If you can tell me what will be the pattern. So tan and cot are, yes, reciprocals of each other, absolutely. So can I form a complete square over here? What I can say, let's see, if I say root a tan x, right, minus root b cot x whole square. So what this value would be? This will be a tan square x plus b cot square x. This is what you people have, and it will have a term. What extra term this will have? Minus 2 root a root b into tan x into cot x, and obviously this will cancel out, and this is the extra term. And if I add 2 root ab, then I can say this and this particular values are equal. Got it? So now let me just remove this particular stuff here. Okay, so now if you tell me that this is your particular function which is something square plus 2 root ab, and a and b are both positive, can you tell me what will be the minimum value? What could be the minimum value of a square? Yes, this could be 0. So the minimum value of fx, is nothing but, yes, 2 root ab. Straight away we got the answer. If you had tried to go on by the derivative approach, it would have become a bit lengthy. It is completely straight away. So figure out the pattern wherever there is a 1 in the question available. So now we know that the maximum value of this particular quantity is nothing but 2 root ab. Okay, so now let's take this function as g theta, which is a sine square theta plus b cos square theta. Now can I form a pattern again over here? It is difficult now because they are not reciprocal pairs of each other, because you will here, if you see, this particular component was constant, right? And this particular component was a variable, but it was in the square, so minimum value we could have said that it is equal to 0. But here if you will do something of 2ab to minus 2ab, you will again get both of them variables, which will not help our case. Now let's say if we differentiate this one, so what value you will get? It will be 2a sin theta cos theta, and this will be what? Minus 2b sin theta cos theta, right? And if you see, if I combine, this can become a minus b sin 2 theta, right? And you need to find the maximum value. So maximum value will be occurring at the root of this. So if we find the root, that means this could be 0 because a minus b is not 0. So that means this 2 theta is equal to 0, or it could be equal to pi, right? This could be the answer. And if we say that theta is equal to 0, then does it make sense? We'll see it. So let's say if theta is equal to 0 or pi by 2. So let's say we are just taking these two extreme points. These are the two extreme points. Now we want to check at which one of these you will get the maximum value, because you need to find the maximum value. So let's double differentiate this. You get g double dash theta as, well, now it's a very simple function. We can very easily differentiate. This will become 2 times a minus b cos 2 theta. What is g double dash theta at 0? We want to find g double dash theta at x equal to 0, let's say. So this will be 2 times a minus b, right? And let's say what will be the value when we say g dash pi by 2. Sorry, yes, pi by 2. Now tell me what will be the value. So this value will be nothing but negative of this particular value. Now let me ask you, which one of them is for maximum? What you will get? Double derivative should be negative. So let's see the sign of the double derivative. It is given that a is greater than b, so that means this is positive, and this quantity will become negative. And you want for, so if I just start solving here, so for maximum, yes, we need that the double derivative at alpha should be less than 0, and this is happening for x is equal to, or let's say theta is equal to pi by 2. So theta is equal to pi by 2 will give you the maximum value of g theta function. Just compare it, what it will become. So maximum value will be what? When you put theta is equal to pi by 2 over here. If you put pi by 2, it will be nothing but a, right? So you want to compare this now with 2ab. It is given to that the maximum value is equal to the minimum value of this, and we have found minimum value is nothing but this particular answer. Just simply square and we will found our answer, right? So this is nothing but a is equal to 4b, hence proof. This is the answer we were looking for, and this is how you will solve questions similar to this pattern. Now let's take the next problem. Here you want to find the greatest value of the function, which is something like x plus 1 raised to power 1 by 3 minus of x minus 1 raised to power 1 by 3. Okay, so for greatest, again we will start with finding the derivatives. So if we start with the derivative, what will be the derivative? Yes, so x plus 1 raised to power 2 by 3, and this will be what? Minus 1 by 3 x minus 1 raised to power 2 by 3. Okay, and if you try and simplify, what you will need to find here is that you will be requiring to solve this particular stuff. We'll come to this, but first of all, let's see what is happening. So I've done a mistake here. Can you tell me what is the mistake? Yes, so this is minus 2 by 3. This is what we do. Commonly we do this error. So if we see this, so 1 by 3 if I take common, so this should something look like this, because this will now come in denominator and this will also come in denominator. Okay, now can you tell me what values of x are there for which f dash x is not defined? Is not defined. Can you tell me? Yes, so x equal to plus minus 1, at x equal to plus minus 1, f dash x is not defined. Why? Because you can say it is in the denominator, so it will not be defined. Okay, so we will talk about this because this is also our critical point, as I told you in the earlier concept, that it is also critical point where f dash x is not defined. So now if we have to solve that f dash x equal to 0, so what this particular quantity will become, that f dash x is equal to 1 by 3 times x minus 1 raised to power 2 by 3 minus of x plus 1 raised to power 2 by 3 divided by x plus 1 2 by 3 and x minus 1 raised to power 2 by 3. So if this has to be equal to 0, that means the numerator should be 0. You can say x minus 1 raised to power 2 by 3 is equal to x plus 1 raised to power 2 by 3. So how do you solve this particular problem now? Is that if you immediately do this, that you cancel the power, what you will get is something of this sort, which is never true. Whereas this has to be solved something like this. So if I say, if you cube both sides, so this is what you will get, right? Cubing, I can say I have cubing both sides. Okay, so a square is equal to b square. let's say understand it this way, a square is equal to b square, so that what you will say, a is equal to plus minus b. So this is just one component that you will say a is equal to b, then x minus a is equal to x plus 1. No problem, you do not get the answer, but this could have also been true if this was the case, right? And if you solve this, what it will become? It will become 2x equal to 0. So this implies x equal to 0 is the point which we were all trying to find. So this is the point that we were all looking for. So now we have three critical points, right? So three critical CPs. So x is equal to 0 and x is equal to plus minus 1. So these are the three critical points that we have obtained till yet. Now we need to find the greatest value that will be obtained. Okay. So out of these three, we know that x equal to 0, right, is a point of maxima or minima, right? Because f dash x equal to 0 is coming out. Now, can we check whether this is a point of maxima or minima? By just orally doing it, we need to find the change of sign of f dash x about 0. Can you tell me how you can do orally without going to double derivative? Because double derivative is a lengthy approach, remember, right? So if you just see that this is the numerator of f double dash of f dash x, and this is the denominator. So denominator is completely a positive quantity because here you are having power 2 by 3. To power 2 by 3 will make everything positive because of 2 square, you will do square and then you will take cube root and they are multiplied, right? So this is positive. Denominator is positive. Whatever will come from the sign will be only for the numerator, will give you the sign. Now how will find the sign? So let's say if I am coming from the left hand side of 0, that means it will be a negative fraction. So this will become what? Minus something, minus 1. So this number eventually inside will be a number greater than minus or less than minus 1, and when you square it will be a number greater than 1. Got it? Now let's say if I put negative over here, so this will be a number less than 1. Obviously here it is a number less than 1, here is a number greater than 1, its cube root will be greater, its cube root will be smaller, so you will have plus sign here. And if you apply the same concept here, it will be a negative sign on the right hand side, and you are going from positive to negative. That means this is a point of maxima or minima? Yes, it's a point of maxima, as simple as that. Okay, so this is how you have to solve in engineering entrance examinations, where you can solve it very quickly. So we know that this is a point of maxima. So now just quickly solve what is f0. If you just put f0, what is coming out? This is 1. This will be minus 1 raised to power 1 by 3. That will be again 1. So minus 1, minus 1, minus 1. Yes, it will come out to be 2. Now tell me what are the values at the other extreme points, that is f1 and f minus 1. Though we need not calculate f minus 1 because the range or the domain of x is given to us is 0 to 1. But still, let's see. First of all, let's find out f1. What you will say to f1? This will become 0. This will be 2 raised to power 1 by 3, right? And if I talk about minus 1, so this will be 0 here and it will become what? Again 2 raised to power 1 by 3. Okay, if we were asked to. So if you were asked the greatest value, so what answer you would get? In fact, if you were to ask in this particular domain, so at f0 you are getting 2, that is the maximum, and at the boundary point you are getting 2 raised to power 1 by 3, and the other boundary point is itself 0, right? So at x equal to 0, it is actually that boundary point and the global maxima has coincide. So the global maximum value is nothing but 2 only, right? This is how you solve these kind of questions.